Kelleway's conditioning and maintenance cubes are a high-protein conditioning cube, ideal for horses in need of a maintenance feed to those in hard work. It maintains body condition without the extra energy that comes with a high-fibre or molasses feed. Our feed is free from barley and molasses, so it's perfect for horses with allergies to either of these ingredients. It is instead high in wheat and soya, which provide the extra digestible energy in the form of protein and oils. Our conditioning and maintenance cubes contain micronized wheat, nutritionally improved straw, wheat feed, micronized peas, soya hulls, soya oil, natural and added vitamins and minerals. The added supplements are MSM, chondroitin sulfate, hyaluronic acid, copper and zinc, all of which aid in the maintenance of healthy joints. Nutrient analysis of this feed shows that it contains 14.85 megajoules per kilogram of digestible energy. It also shows that the feed is made up of 13.7% crude fibre, 14.9% crude protein, 2.5% oil and 0.02% ash or vitamins and minerals.
The horse is a hindgut fermenter. The normal functioning of the fermenting process is dependent on orderly delivery of contents, maintenance of a balanced environment within the digestive system, limited fluctuations in pH, and rapid absorption of nutrients. 2/3 of the digestive tract are devoted to fibre digestion through fermentation, while just 1/5 is designed to process starch from cereals, oil, and protein. For horses in light work, feeding regimes match digestive design, as most of their diet is forage. For working horses, low-energy forage does not provide sufficient energy, so cereals and oils are added to make up the shortfall. Starch levels in the diet must be limited, as the hindgut is not designed to process starch. Too much starch in the hindgut can induce colic and cause changes in behaviour. Fibre is composed of complex carbohydrates and compounds, which are broken down by bacterial fermentation in the hindgut. Fibre is made up of lignin, cellulose and hemicellulose. Lignin is indigestible, so feeding a horse food with high lignin levels, such as straw or mature seed hay, is great for filling them up while providing them with a low-energy feed. The cellulose and hemicellulose found in fibre are digested by bacteria in the hindgut. The higher the levels of cellulose, then the more energy is found inside the forage. Fibre should be present in the diet of all horses, particularly those being fed a low-energy feed, as well as performance horses. Energy in fibre digestion is slow release, so is capable of sustaining work for a long period. As a minimum, a horse should consume 1 to 1.5% of their body weight in forage per day, equaling about 15 pounds of hay. It is critical to maintain energy balance, providing enough energy to meet exercise demands and to maintain body condition.
Proteins are complex molecules that are present in all living organisms and are major components in muscles, enzymes and many hormones. Protein is species-specific and organ-specific. For example, a cat muscle protein is different to horse muscle protein, and muscle protein is different from brain protein. Animals cannot synthesize all amino acids, but all amino acids are vital for life, so some must be supplied by the diet. These amino acids are called essential amino acids. For example, lysine is an essential amino acid for the horse because the horse is unable to produce this amino acid itself. The protein content of plants is very low, so herbivores such as horses must eat a very large amount to reach their protein requirement. Proteins are very large molecules made up of single amino acids joined together by peptide bonds. There are roughly 20 different naturally occurring amino acids, and different proteins have a different sequence of amino acids. Proteins with a similar function will also have a similar structure of amino acids. Protein is digested in a number of steps, starting in the stomach and ending in the small intestine. First, pepsin, the protein digesting enzyme, is produced in the stomach and breaks down the peptide bonds, holding the protein molecule together, turning the protein into a polypeptide, which is a smaller amino acid chain. Next, trypsin, chymotrypsin, and carboxypeptidase are produced by the pancreas and enter the duodenum via the pancreatic duct. These, along with brush border enzymes, which are found in microvilli, break down the polypeptides into peptides, which are even smaller amino acid chains, and then break down the peptides into single amino acids. Single amino acids are so small they can be absorbed through the wall of the jejunum in the small intestine, entering straight into the bloodstream. A horse's protein requirement depends on the needs of the individual, the quality of protein available, and the digestibility of that protein. Protein is needed in the horse to maintain body weight and energy levels. Although protein seems to have little to no change in requirement with increased energy levels, nitrogen does, and nitrogen is often obtained through protein because nitrogen is part of the protein structure. The influence of protein quality on the growth of young horses has been shown in many studies. For example, foals fed linseed protein grew slower than those fed milk protein, and maize protein has been proven to be inferior to soybean protein. However, mature horses seem to be less sensitive to protein quality than growing horses or horses with a high workload. Protein sources such as soybean meal may have greater effect due to a high digestibility rate. Even just for maintenance, a purely forage diet is unlikely to supply enough protein to meet the horse's requirement due to the low digestibility of the proteins found in forage foods such as hay or grass. Inadequate protein in young horses can lead to decreased growth and development. In mature horses, inadequate protein intake can lead to decreased food intake and therefore weight loss, poor coat quality and reduced hoof growth. However, an excess of protein intake may cause increased thirst and water intake, slight growth depression in young stock, and reduced performance in mature horses. Fats are also known as lipids and include oils, fats, wax phospholipids, and steroids. Lipids are all organic compounds because they're composed of a series of hydrocarbon chains ending with groups of bonded hydrogen and oxygen and are all partially insoluble in water. Lipids are also hydrophobic because they are made up of long hydrocarbon chains with only a few oxygen-containing groups. Some lipids, such as oil, are non-polar because they consist of a hydrophobic or water-hating tail and a hydrophilic, water-loving head. Lipids can be either solid or liquid at room temperature, with solid lipids containing less carbon-carbon double bonds, and liquid ones containing more carbon-carbon double bonds. All lipids are made up of carbon, hydrogen and oxygen, and their structure varies depending on the type of lipid. During lipid digestion, the liver produces bile which has been secreted into the duodenum of the small intestine via the hepatic duct. The bile then emulsifies the fats, breaking them down into smaller units. Lipase, a fat-digesting enzyme, which is found in pancreatic juice, is also secreted into the duodenum via the pancreatic duct. The lipase then chemically breaks down these smaller units into units called monoglycerides and free fatty acids that are small enough to be absorbed by the body. Lipids are then absorbed through the wall of the jejunum in the small intestine and are carried by the bloodstream to whichever cells need them. As horses grow older, digestive enzymes, teeth and liver all deteriorate, making the horse more susceptible to environmental factors. This means that a senior horse will require more energy to maintain a healthy weight. Since fat is a good source of energy, an older horse may require a diet slightly higher in fat. However, this should be within reason because excess fat will be stored as adipose tissue and can lead to other health problems. Foals often have a lower body condition score and so have higher calorific needs, which could be found from fats since fats do not cause the same potting up effect that carbohydrates can cause. Potting up is the term used when a horse has an explosive amount of energy. Breeding mares, stallions and competition horses may also benefit from a high fat and low carbohydrate diet for the same reasons.
Ash refers to any inorganic materials that remain in food after heating. Food is ashed to examine the leftover food content. Feed is heated to extremely high temperatures under laboratory conditions and is then measured, with the percentage being based on how much food there was at the beginning of heating and the amount of ash remaining at the end. This final percentage is what is listed on food labels. Ash can include both compounds with essential minerals, for example calcium and potassium, as well as toxic materials such as mercury. Natural foods usually contain less than 5% ash content, while processed foods have 10% or more. Ash usually contains the remains of mineral additives that have been used to enhance the feed. The main components are usually phosphorus and calcium, as well as minerals such as iron and zinc. The ash value describes how much of the feed is composed of minerals, which is useful for owners who need to limit their animal's mineral intake. Too much ash in the diet can cause crystals to form in the kidneys and the bladder. Excess minerals can cause bone and joint problems in horses, so they should avoid being fed a diet with a high percentage of ash content.
There are 5 supplements that have been added to Kelleway's conditioning and maintenance cubes: MSM, chondroitin sulfate, hyaluronic acid, copper and zinc, all of which aid the maintenance of the horse's joints in some way. MSM is a form of organic sulfur which is used in the formation of connective tissue. It also has an anti-inflammatory effect, although it is unclear exactly how this works. One equine study on horses with hook arthritis showed that a dose of at least 20,000 mg per day is effective in reducing arthritic symptoms. Chondroitin sulfate helps to build cartilage and bone. has some pain-relieving qualities and helps to prevent further breakdown of cartilage when it has been damaged. It is the main polysulfated glycosaminoglycan, or PSGOG, a long-branching sulfated molecule in articular cartilage. It has two main forms, both of which protect the cells of the cartilage found in joints, but only one can be absorbed when given orally. Chondroitin sulfate can trap water within its matrices, which gives the articular cartilage its unique resiliency to concussive force. Only around 30% of the molecules found in feed are absorbed by the body due to molecule size, as only the smallest are able to pass through the intestinal membrane. Hyaluronic acid is an important component in cartilage and joint fluid. In normal joints, a gel-like layer of hyaluronic acid forms an elastic cushion between the joint surfaces and behaves as a shock absorber. If this layer isn't present, the surfaces are submitted to a mechanical wear, like in some forms of arthritis, which can cause significant pain. It was first used as a drug in the 1970s in an injectable form and is now available in an oral supplement and a gel. It has properties which relieve and control pain, heat and swelling. Copper and zinc are both highly important in the body's antioxidant systems, and copper also has a role in connective tissue formation. Most equine diets are low in both minerals, needing up to 50 mg per day of copper and 150 mg per day of zinc. A deficiency in copper has been linked to skeletal deformities in foals, so it's especially important to keep the levels of copper in a broodmare's diet at a good level.